Sometimes 3D printing is actually the best solution for something. Y'all saw the video where I spent way too much time forming this piece of plastic for battery tray. Now I'm going to show you what I did next. This battery tray definitely worked better than the cardboard, but it also looks like maybe my kid made it or I sculpted it out of butter. It totally works. It's hidden, it's cool, it's, you know, it's whatever. But when I got everything all over here, my 3D printers, my computer, my rigs, as you can see, I 3D printed another battery tray. I printed it in green just so you could actually see it on camera a little bit easier because the black totally hides in there. But I will share with you exactly what I did, how I made it, and also how I sliced it. So we're just gonna dive right into our SolidWorks here. But as you can see, it just kind of slides right in, and it actually holds a full-size hard pack as well. Ooh, let me grab one. All right, so maybe this one isn't actually a hard case, but this is the same size as a hard case. 3S 5200 milliamp hour batteries. How long could I crawl with this? Forever, really. So there, you know, it fits a little better than this would. With the way that this was just kind of, you know, lumpy, it wouldn't quite fit. So usually I don't use that size of battery, but let's just take a look at the design, why I designed it or how I designed it. It's pretty straightforward. So as you can see, it is just a U. It's a U channel, and it's as long as it needed to be to fit. Here we go. F fits full screen in this software, SolidWorks. Alrighty, let's see which side is my sketch on the opposite side. So we're going to normal to that so it faces us. Then I'm going to just show you with an edit here what I did. All right, looks like I've got way out here. We'll pull these in so we can read them. There we go, a little bit better. Now, F in the chat. So as you can see, the inside down here is 29 millimeters wide. The outside is 33 millimeters wide, which that's not actually a driving dimension because I set this to be 2 millimeters with wall thickness. And the reason why I use 2 millimeters is that I'm using a 1 millimeter print nozzle. And so that's just 2 walls, nice and quick, nice and easy, nice and strong too. I love that 1 millimeter nozzle. And then as you can see here, 30 millimeters tall from base to top. And I did 30 millimeters because it would fit in, and it just seemed about right. You know, you don't need anything too tall. I also needed enough room to pass the wires by, which I could have done a cutout on one of these sides or just manually cut it out with a knife or some snippers afterwards. But that was enough for pretty much any battery. So why waste material and print time when you can do something that gets the job done, right? So that is our dimensions. If you want to draw this yourself using Fusion, this is what you would do. Exactly, just copy what I did, and as long as your printer isn't way oversized, it's gonna drop right in. So there you go. That is what that looks like. Now for the next step, we did a extrude, boss extrude is what they call it in this software. So we're gonna look at that through the edit feature. And as you can see, 142 millimeters. If you want to recreate this, that is how long you need to make your extrusion. Any longer, and we're going to actually end up running into these, like, it's kind of like a chamfered edge right here, because the battery tray, the original battery tray is not exactly square. It's a rectangle, I suppose. It's got that sort of shaped side to it. So if I remember correctly, I don't remember if I used this or if I just like printed one and did it fit. Sometimes that's what you do. So 142 millimeter length there on the extrude. Now, after you do this in a software, we're just gonna save, and then you would do a save as in pretty much any software, and you're gonna export as an STL type file. So as you can see, we've got all sorts. SolidWorks is the native, you know, PRT or SLD PRTs. We've got 3MFs. I'm not going to read all of these, but you can even do outputs for Photoshop. You can do PDFs. Now that's just going to be a 2D, like a snapshot of what you're looking at for that kind of stuff. If you are going between different softwares, you're going to be using something like a step file down here. The 203 step file is the original step file, and the 214 encodes things like color, if I remember correctly. Then here we go, STL right there. That's what we would use. As you can see, I've already saved it as the battery tray. Then what we do is we're going to import it into our slicing software. All right, so we're gonna close this out here. We're gonna go to our slicing software. Instead of laying it down and printing it and having the lines going this way, I printed it so the lines are gonna be going this way when it's printing upright. The reason why I did that is that you're going to see, I'm going to see loads in this direction when you're crawling. And that's where it needs to be strong. So if you can imagine, we've got kind of a U channel of plastic just stacked on top of each other like that, all the different layers, that it's not gonna break typically in that sort of orientation. Now I would say maybe there's a chance that if there was direct pressure in the middle, that the bottom could break out in this orientation. But I've got a battery that's going to be stretching across the entire thing, so that's really not going to be a problem. If you feel like you need more strength in that, you know, long supported angle, like if you were putting weight in the middle and you're supporting it on the sides like this, then you could print it sitting this way as well. But I felt like for this particular item and how I wanted it to be strong, I printed it this way. So a lot of what printing involves is actually thinking about how it's going to print, how it needs to be strong, and then designing your part according to that, and then also printing according to that as well. So here's the item. It is on the plater right there, as you can see. And we're gonna look at my print settings. So I use a 1mm nozzle. What we are interested in here is our layers. I do the first layer height at 0.2mm, just so 0.3 is a little tall a lot of times. So I do 0.2mm layer height on the first, and then 0.3mm layer height on all the rest. The reason why I chose 0.3 is because I've got a 1mm nozzle, and this is a little bit less than a third. And that's a pretty good, I usually do a third, basically. Whatever my nozzle size is, I'll do a third, unless if I'm using a 0.4, usually I'll do like maybe a 0.2 layer, even a 0.3 layer, just because I kind of like the thicker layers. I'm not going for something that's just for looks. I want something that's structurally sound, and the thicker layers usually provide that. It also is faster to print when you do thicker layers, as long as your hot end will keep up, which is really that's a different video there. So this is only 2mm wide. One perimeter shell would be enough for it, but I just typically use 3, especially with a 1mm nozzle. Same for the horizontal shells. This isn't going to matter on this thin feature sort of item, but again, I would do 3 layers top and bottom. That's going to end up being 1mm, since our, you know, it's 0.3. I guess it's technically 0.9, almost a millimeter for our top and our bottom. 3 layers, 0.3mm per layer, etc., etc. Infill, it's a thin feature, so it doesn't matter on this one. Skirt and brim, if I was having problems with it not sticking to the bed, this is when I would use a brim on it. But, you know, 1 loop or 2 loops, basically, you can do this way, or you can do a skirt that has a distance that is 0 from the object. It's the same thing pretty much. Support material, don't need it on this, so we can ignore. All right, so right now this is set for PETG structural. If you go to my other setting, you can see if I'm doing PLA plus, I'm going to be going about 60mm a second. I do slow it down for the outside. For small holes, I go down to 15mm a second. External perimeters, as you can see, 70% slowdown, so that's going to be about 18mm a second slower, so roughly 40, whatever that was, 42 millimeters a second. Infill, I go fast on infill as long as it's not PETG, because it hates it. So as you can see, 80, you know, get it done, but there's no infill on this, so it doesn't matter. Top and bottom, I go with a much slower setting so that it looks good. It doesn't really matter on this because it's just going to be the end again. There's a lot of things when you have a thin feature like this that doesn't even matter. It's not going to be effective. Bridges, gap fill, blah, 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 a bunch of stuff that, again, doesn't matter. Travel, 130mm a second. I should probably bump that up to like 500, let's see. Yeah, I should bump that up to 500, just forgot to do that. Usually the faster the travels, the better. You don't have as much time for your oozing. First layer speed, that slows it down. You always want to have a first layer speed that's going to adhere very well and not stretch your plastic too much. So I usually go to 50%, which would be 30 millimeters a second for the settings that we have right now, which is fine for something like PLA or PLA Plus. If we were using PETG, that would be like 10 millimeters a second. PETG does not like to be stretched. All right, so now we're going to go to the advanced settings. Extrusion width. I've got a 1 millimeter nozzle. I'm printing with a 1 millimeter extrusion width. You could do something different. You could do a 0.5 millimeter, and it would still work fine, honestly. I have printed it at 0.7 millimeters, actually just switching files from one printer to another. One has a 0.7, the other one has a 1 millimeter, and it works just fine, actually. It doesn't, you don't really have to do the exact extrusion of your nozzle. And a lot of people do like 1.2, make it even faster, but 1 is so fat anyways that I feel like I need a little bit more accuracy and precision rather than just trying to as much as I can. All right, so 1 millimeter all over, as you can see here. Overlap. This is kind of important on other things, not on this. This defines how far your infill goes into your perimeter's edge. I do 25%. If your machine has backlash, you may need more. Sometimes you may need less depending on how your machine handles the G code as well. But I typically go for 25% because on a round object hitting pretty much a flat line going sideways, you get about, that much overlap, really accurate with that illustration there. That you get enough overlap so that you have adhesion on the edges where it kind of like bumps into it, and then you go out. The problem that you can have if you have too much overlap is that you over extrude if the layer is also at 100% infill. So just watch out for that. This is something that you're going to have to tune for each machine, but typically I like 25% as just an overall always. It looks like here 15% is that maybe they don't have something that's standard on here. Yeah, anyway, 25%. Bridge flow ratio, we don't even need to talk about that. Slicing, this is all advanced stuff. Really, I don't mess with it much. Yeah, we'll just ignore that because we don't want to spend too much time explaining things that don't matter today. All right, output options, we don't need any of that. We don't need any notes. We don't need any dependencies. All right, so we go back to the plater, and this is Slicer. Same thing as Prusa Slicer. Maybe this is Prusa Slicer. This is, haha, it's the same program. So as you can see, I had one loop around the outside. That's that green down below, skirting the brim. The reason why I did that is so that we can prime our nozzle. Really know the reason. On a lot of my other ones, I have some G code where the nozzle just goes and that's primed. On this particular slicer, I don't have that yet. I might go to it. Sometimes it's handy, sometimes it's not. So yeah, there's our priming, and then it's a really simple object. It just goes right up, just layer by layer by layer. Looking here, it says it's 41 minutes. I didn't really push the speed too much. So, yep, there you go. That's the object. I could print another one, I suppose, but the green, I don't know, I kind of like the green. What do you think? Should I do something in black? Should I do something in purple? Or should I just keep the green? Yep, there we go. So hopefully that helps on some of the process for this, the design process, the slicing process, which is almost its own set of skills. If you do have any questions, leave them down below. We'll do our best to get to them. And in the meantime, thanks for tuning in and have a great time printing.